Kia ora, Year 12 and Year 11. This is a question that I'm doing for Aditya from the Winter AS 2018 Pure paper, and it's got lots and lots of really good stuff about functions in it. So here are the 4 questions here. So for some of you this is going to be too slow, but for most of you I think there'll be some good revision in it, so it probably is worth watching a fair bit of it, hopefully. You can just put me on to 1.5 times and speed me up a bit. I'm going to chuck the mark screen up now, mark schedule up for you now, for those of you who are going really fast. So you can just pause that and have a wee look at that. Okay, so back to the questions. This kind of follows a classic format that we start out with a parabola and we're told to do completing the square on it. In other words, get the parabola into vertex form, and we're going to work with that vertex form for most of the problem. Vertex form is unbelievably useful whenever you're dealing with any kind of question to do with domains or ranges or inverses. I'm going to have a look at why in a minute. So first we have to figure out what vertex form is, and then we have to do something to do with one-to-one functions. We have to find the inverse and state the domain. And lastly, we need to do a composite function thing and figure out when that is valid. Right, so I'm going to go through each of those parts much more slowly, but completing the square form is something that you should know by now inside out, so I'm not going to take too long to do that. So if you need more time on that, where's my function? We've got 2x squared. If you need more time on this, go watch the video about completing the square. So we put a box around there and we go 2 into x squared minus 6x plus 11, which is equal to 2 times x minus 3 squared plus 11, and then we take out the 18 that we've accidentally added in, and we get 2 times x minus 3 squared minus 7. Now that lets me see straight away that the vertex is going to be here and down at about -7. So let's see what we're going to have there. We're going to have 2 9s, so it's going to go something like this. Now, I'm going to show you a good graph of this in a moment, but this is enough for us to start talking about the ideas of functions. So as I've drawn that, this is a function, right? Because for every x value, I get out a unique y value. And the way that we measure that in maths is with a thing called, where are we? The vertical line test, right? So the test for whether something's a function is, does it pass the vertical line test? So if you take your ruler, and you should do this in the exam if you have a freak out moment and can't remember, this passes the vertical line test, so it's a function, right? But it's not invertible as it stands. So what do we mean by invertible? Well, the idea of an inverse is this. Now I'm going to go back to working with the simplest possible parabola, right? So we're going to work with y equals x squared. So y equals x squared is a function, but the idea of an inverse is I want to go, instead of going from x to y, I want to go from y to x. And the way that we can think about that graphically is by doing a reflection in the mirror line. Mechanically, what we do is we say x is equal to y squared, right? And now we want to make y the subject, and so we get y is equal to plus or minus root x. Now, algebraically, that's a totally fine, glorious thing to do, but here's the graph that we get if we try to draw this, right? So if we draw y equals plus or minus root x, it's going to look like this. Let me find a nice colour pen. So the points that won't change are the ones on the mirror line. And I'm going to draw a bad graph now like that there. So that's what I get instead. The problem is that that's not a function, right? So that means that we say that this function that we had to start with, although it's a function, it's not something that we can invert because we don't end up with a function for my answer. So what we need to have for something to be invertible is we need to have a one-to-one function. And the way that we do that is we limit the domain. And the way that I'm going to limit the domain here, I'm going to try and erase just half of this. If I just, oh, it worked, amazing. So now, if I limit my function to be just that positive part, you can see that this function can be inverted, right? Because now, oh, where's my pen? Oh, there we are. Still not working. There, that's my inverse function. And I've done it by limiting the values. So one more time, if we go back to this function here, it's not one-to-one, but I can make it one-to-one by getting rid of one side of the one side of the parabola. And now what I've got is a function that passes both the vertical line test and the horizontal line test. So you can see that by putting my function into vertex form, it's really easy to see how I can make that function 1-to-1, right? So state the largest value of the constant k for which f is a 1-to-1 function. So in this case, we're looking for the domain to be restricted to x's less than a number. So we're leaving ourselves with this side of the parabola. So k is equal to 3, right? Because I can go up that far before I lose my 1-to-1 property. As soon as I go further, I'll have this bit around here, and then I've failed my horizontal line test. So that's the first 2 bits done. Now, I've gone slowly through that, because if you don't understand that well, you get into real trouble once you start trying to do domains and ranges. So just clean up this a bit. So that's the first 2 bits done, and we've already used up 5.5 minutes. Now, the next thing we have to do is, assuming that we're limited to x less than or equal to 3, we have to find an expression for the inverse, and we have to state the domain of the inverse. So let's clean all of this up. Okay, so we're going to find an expression for the inverse, and here's how we do it. Right, so when we do inversing, we always go like this. We start with our function, and we mechanically swap over the x and the y. So we write it like this. If you work with vertex form, these questions are always really easy. If you try and expand it out and go that way, you end up with the quadratic formula or another completing the square problem, and they're a bit messier. So my strong preference is to do it like this. So we get x plus 7 over 2 is equal to y minus 3 squared. Next we get this. So we get y minus 3 is equal to either one of these 2 branches, but we're going to choose one of them. We just have to do that quite carefully. So now we get y is equal to 3 plus or minus x plus 7 on 2. But here's when we start to do something useful with the idea of the domain and range. So in my graph, remember back when we did the simplest case where we had y equals x squared. When we restricted that to make it a 1-to-1 function, we can say, well, where does my inverse end up sitting? Right, so here, this is here, and this goes kind of like that, right? And that's kind of like what my parabola is now. So you can see that because I'm dealing with my domain being x less than or equal to 3 for f, then my range is going to be, in the new one, my range is going to be less than or equal to 3. And that means that I want to have the minus branch here. Okay, so my answer here is not what I've written there, right? That's not a function, because that's going to give me 2 halves. So my answer here is going to be y is equal to 3 minus root x plus 7 on 2. Now I want to show you a nice way to get the domain and the range right, because that's the next thing we're asked about. What's the domain of the inverse? And the basic idea here is that what I'm doing is I'm swapping the domain and the range over. So if you do this little chart, I don't think you're ever going to go wrong. Maybe you are. So my domain here was x less than or equal to 3. That becomes my range. So now in the inverse, y will be less than or equal to 3. Here, my range for f was y is greater than or equal to negative 7, and that becomes my new domain. And you can see that in the function, right? Because here I've got, oh, wrong pen. That was just bad. You can see that I've got x plus 7 in my top line here. So I've got to have values of x that are negative 7 or more, otherwise I'll have an imaginary number. We don't want that. Not an AS. Okay, so that's the first bit. So the domain here, the domain of f inverse is x greater than or equal to negative 7. Right, hopefully so far so good. Please leave me some comments or send me an email if this is not making sense yet. So we're nearly there. The last bit looks horrible, but it's actually really easy if you, again, understand what a domain is. So we just have to read through a whole lot of words. With k now taking the value of 1, well, what was k? K was the domain of my function f. All right, so we're saying f of x is equal to 2 times x minus 3 squared minus 7, and now it's for x less than or equal to 1. So the only numbers that I'm allowed to put in to my function machine are x below 1. Right? So we've got a new function, which is g of x, which is some number plus 3. And we want to form a composite function fg. So fg means take g of x and put it into my f machine. So the easiest thing to do is first of all to work out what is f of g of x. And then we can talk about what this constant p is. So working out f of g of x is pretty straightforward. G of x is x plus 3. So everywhere that I see x being input into my function, I replace it with g of x. So that means that I'm going to have 2 times x plus 3, take away 3, squared minus 7, which is 2x squared minus 7. So that's fine, except that I'm only allowed to put in numbers below 1 into my f machine, right? So when I'm putting in x plus 3, because I'm putting in g of x, I have to have that restriction holding, right? So we need x plus 3 has to be satisfying that restriction as well. So x has got to be less than or equal to -2. But just be careful, we're not asked to write it exactly like that. We're asked to say what is the value of the constant p. So we're just about there, but if you stop at this point you won't get the mark for this, right? Because the question says my function g of x is defined for x less than or equal to p. So what we're asked to do is to find the largest value of the constant p that lets us form that function. So here we have to write down p is equal to -2. Okay, so there's a lot in here, and if you're not confident with any individual bit, what you need to do is do lots and lots of practice. This is a really great topic that we do in AS, and it does start to hang together pretty quickly. So the booklet that I've emailed you out that's got lots and lots of functions questions is probably a good place to go now. And I'm really happy to do more videos on any question there that you can't do. So go and have a watch of that, go and have a read of that, and I've sent you out the worked solutions as well. Please let me know what other topics you want me to do revision on, either with YouTube's or worked solutions over the next couple of days. Okay, thanks for watching.